Hi everyone, welcome back to my channel. If you are new here, I'm Shivani, a student diving deep into the exciting world of data science. I'm thrilled to have you join me on this journey. This is the video 9 in my data science series where we will be exploring key topics. Today we are diving into regression modeling. Regression modeling is a static technique used to understand and predict the relationship between variables. It is the fundamental concept of data science, machine learning, and predictive analysis. The goal is to create a model that captures the relationship between dependent and independent variables, enabling us to feature predict and the outcomes of the existing patterns. There are four steps in the regression model. The first one is the data collecting. Gather the data set and contain the independent and dependent variables. Then we data process, handling missing value, normalizing and addressing the outliers. Model building, that is also data transformation. For the designation model to data and libraries like skitskills and statmods in Python. Then we understand the model and the coefficient to see how independent variables influence the variables. Use the model to predict outcomes of the unseen data. Let's see the Python implementation. Let's start by building a simple linear regression model using Python. We will use skitskill-learn libraries and a sample data of car prices with features like car age and mileage. So here we have created a simple dataset and selected age and mileage as their predictable values, and the target values is the price. So now let's split the data into training and testing and then see then fit for the regression model. We have trained the model using our training set and then evaluated it on the test set. The mean squared error helps us to measure the average of the square difference between the predicted values, while the R squared values tell us how our model is fit for the data. Let's run the code. Here we have used xtrain and ytest for the training of x set and the testing of the y set. So we calculated our mean square error and R2 square error of the above given data set. So see, we have our R squared error and the mean square error. So let's understand what is stepwise regression. Stepwise regression is a static method for selecting a subset of explanatory variables in the regression model. The aim is to build a model that balances simplicity and predictive accuracy by systematically adding or removing variables based on specific criteria such as static significance or the contribution to the model. Stepwise regression operates in two primary directions: forward selection and backward selection. Forward selection starts with an empty model. It iteratively adds variable that improves the model the most based on the criteria like p-value, alkyne information criteria, or R-squared. Stop when no additional value meets the in conclusion criteria. Backward elimination, it starts with a full model. It iteratively moves the least significant variable based on the criteria, stops when all the remaining variables meet the retention criteria. So now let's see a Python code for the stepwise regression. The code provided is performing multiple linear regression using stat models in Python along with the backward elimination for the future selection. So first we import our library statmod.api. It is used to statically run models in Python, and here is being imported to run linear regression model. Next we add a constant term. Here x represents the independent variable feature, and add constant adds a column to the 1s to the feature matrix s to account for the interception term in a regression model. Without this step, the model would assume the interception is 0. Then we fit the OLSS means ordinary least square model. Here y represent the dependent variables and OLSS fit the ordinary least square linear regression model. Fit trains the model and estimates the coefficient of the model. Now we print the model summary. This complete block of code is used for backward elimination. It removes the elevative features from the high value p. This condition checks if the high value is p among the features is greater than 0.5. If it is, then it indicates that there is at least one feature that is not statically significant. Now let's run the output. So the initial model is the first model will show the R square coefficient and p value in each feature of x. Feature with p values greater than 0.5 will be considered the candidates for removal in the next step. Next will be the backward step summary. So after the each iteration of while loop, the feature with the highest p-value is removed from the model, and then the model is refitted with the remaining feature and the new model summary is printed. The process continues until all the units of remove of remaining features and p-value is greater than or equal to 0.05, indicating that they are statistically significant. Once the backward elimination has been finished, the final model summary will show only static significance feature. The p-value for all the features will be shown in less than or equal to 0.5, indicating that the model only features that significantly contribute to explaining the variance independent variable. So this is the initial summary till here, and then after the first iteration this will be the result, and the final allegation result will be this. And that's the wrap for the today's video. If you found this video helpful, don't forget to like, share and subscribe. Until then, keep coding, keep exploring. Bye for now.